In this first example problem, we were given some properties in British units. So when I set this up, I'm going to be setting up the three different phases of solid, water, and air, where I'll keep track of the volume on one side. Whoops. I'll keep track of the volume on one side, and I'll keep track of the weight on the other. I'm using weight because we're going to end up using pounds instead of slugs. We're going to just use weight instead of mass, which we normally do. So when we use SI, we probably would use mass like grams or kilograms. But when we're dealing with British units, we'll probably deal with weight instead of mass and just use pounds. So what I'm going to have to do in this problem is assume 1 unit volume. So I'm going to assume 1 cubic foot of soil. And these problems are always hardest to start. And in this case, what you need to recognize is that this information that we have here about what a small sample had a mass that was moist of 127.5 and dry of 118.1 tells us that we had a total of the mass of water equal to the difference between those, 127.5 minus 118.1, or 9.4 grams of water. That allows us to go directly to getting the water content as 9.4 grams of water when we had 118.1 grams of soil. That gives us a water content of 0.0794. So that's our water content. That's going to be essential in order for us to be able to figure out these weights of the soil phases that we are about to calculate. So the next step is that we need to start getting actual weights associated with our assumed 1 cubic foot of soil. Well, if we have the weight of the water, that's a capital W, plus the weight of the soil, we know together those two sum up to, for our 1 cubic volume of material, 122.5 pounds. That's something that we were given with the problem. Once we assume that we have a cubic foot of soil, we know that the weight of the water plus the weight of the soil is going to sum up to 122.5. To find out what these unknowns, weight of water and weight of soil, are, we're going to have to divide both sides of this equation by weight of the solid. So weight of solid, and again these are capital W's that I'm using here. Well, that simply is equal to the water content, so I'm trying to put in a small script W, plus 1 is equal to 122.5 pounds divided by the weight of the solid. So we can get the weight of the solid as 122.5 pounds divided by 1 plus the water content. So that gives us a weight of solid equal to 122.5 divided by 1.0794. So when I completed that, I got a weight of solid equal to 113.4 pounds. So I have my first piece of information here. I know that my weight of the solid is equal to 113.4 pounds. Next, I need to get the weight of the water. I'm going to keep this space and just erase this portion of my work. I can get the weight of water from remembering that weight of water over weight of solid is equal to the water content. So I can get that from the water content multiplied by the weight of the solid, which is equal to 0.0794 multiplied by 113.4 pounds, and I got a weight of water equal to 9.0 pounds, 9.0 pounds. So that's what goes up here. Next, the weight of the water is equal to 9.0 pounds. Okay, from there, it's time to get the volumes associated with those two phases. So from that, to get that, we will use the fact that the easiest one is the volume of the water. 9.0 pounds of water is equal to how many cubic feet? Well, we know that there are 62.4 pounds in a cubic foot of water. So we can just divide 9 by 62.4 to get a volume of 0.1442. cubic feet. So that phase has a volume of 0.1442 cubic feet. Now we need the volume associated with the solid phase. That's just a little trickier. We can get the volume of the solid phase from the fact that we know that there are 113.4 pounds, and we know that there are, the specific gravity is 2.67 times, and the unit weight of the material then would be 2.67 times the unit weight of water, 62.4 pounds per cubic feet, and that'll give us the volume of the solid. And when I divided 113.4 times the product of 2.67 times 62.4, I got 0.6806. 6806 cubic feet. And I enter that up here. 0.6806. Okay, now I need to erase this again. Now we just need the volume of our air, and we can get the volume of the air using, well, volume of the air is equal to 1 minus the sum of 0.1442 plus 0.6806. Whoops. And I got an answer there of 0.1752. So I have my last piece of the puzzle here, 0.1752. And that's also in cubic feet. So we are ready to go right to finding the answers here. And the first thing that we were asked for is the water content, which we got, so that's part of our solution. The next thing that we want is the sampled degree of saturation. And we can get the degree of saturation, and it's just with the big capital S, and that is the volume of the water divided by the volume of the void, and in our case that's equal to 0.1442 divided by the sum of the volume of air and water. So we have 0.1752 plus 0.1442 in the denominator, and I got a degree of saturation equal to 36.8%. So I'll write that one down, keep track of our answers, 36.8%. And the next thing that we're asked for is the dry unit weight and the saturated unit weight. Well, the dry unit weight is actually very easy to find. So we can just write that down now by inspection. There is no, in a dry unit weight, we would have gotten rid of all the water, so the only thing that has any weight here left is the solid phase. So that's just equal to 113.4 pounds per cubic foot. So it leaves us with one item to calculate, and that's the saturated unit weight. So now to do that, what we need to do is to say if saturated, we know that we're going to have the air phase replaced by water, or 0.1752 cubic feet more of water. Now, what we need is to figure out what the weight of that much water would be, and we can get that from 0.1752 cubic feet of water times 62.4 pounds per cubic foot. Just multiply those two. We get an answer of 10.93 pounds of water. So if we add, we can get the saturated unit weight using the moist unit weight plus that additional weight of water. We have 122.5 pounds of water, which is before it gets saturated, what we got in the field, we had 122.5 pounds in our moist soil, but now we just added 10.93 more pounds of water, so that gives us a saturated unit weight of 133.4 pounds per cubic feet. And that's the end of video example problem 1.